The baked Alaska is composed of meringue, ice cream, chocolate wafer crumbs, and pound cake or sponge cake. Here is the process of how to make the baked Alaska. Initially, brush the bowl with vegetable oil. Secondly, line the bowl with plastic wrap. Then fetch the ice cream flavors of your preference and press them down into the bowl. Fourthly, sizzle the ice cream with chocolate wafer crumbs. Then press the crumbs down. Then refresh it for 30 minutes. Next, add more ice cream into the bowl. After that, add pound cake into the bowl. The next step is to line the plastic wrap onto the pound cake and let them freeze for 2 hours. After this, we need to make the meringue. First, pour some egg whites into a transparent bowl. Next, pour some cream of tartar into the egg whites and mix them. Then, gradually sprinkle sugar. After that, whip the solution until it becomes foamy. Fetch the first bowl from the fridge. Then put it upside down and take out the bowl. Undo the wrappers and apply the meringue onto the ice cream. Freeze for 3 hours and then bake them at 500 degrees Fahrenheit for 4 minutes. You might be surprised that when the baked Alaska was baked, the ice cream did not melt. But the reason behind this is simple. The meringue acted as an insulator and prevented heat from entering into the ice cream. This is because of the color of the meringue. Inside the oven, heat is being radiated into the baked Alaska, but because of the white meringue, heat is reflected. Radiation is the transfer of heat through the use of waves. The white and silver colors reflect heat at best, while the black color absorbs the heat. The white and silver color reflects heat best, while the black color absorbs the most heat. Radiation is only the first method of heat transfer. There is also conduction and convection. Conduction is the transfer of heat using the vibration and collision of particles, while convection is the transfer of heat in liquid where the warm rises and the cold sinks. The next part will be presented by Shinati or Jedi, and he will be talking about how the baked Alaska will undergo transportation to the chef's restaurant, and he will talk about the containers that will house the baked Alaska. Here's Shinati. Welcome. Please cut that. You can cut that out.
So in this next part, we'll be talking about the container. The container must be an insulator. So once the baked Alaska is finished, it must undergo transportation from the chef's restaurant to the customer's home. If we were to transport the baked Alaska with no insulator to keep out the heat, the baked Alaska would surely melt under the heat of the sun. This is why we need to construct a cooler to house the baked Alaska and prevent the heat from entering. This cooler will be used to insulate the heat and keep the baked Alaska cool. So in this bar graph we have here is a bar graph comparison of different boxes together. So we have a metal box, a plastic box, a foam box, and our insulation method box. So as you can see here, the amount of ice that is in the container decreases a lot for the metal box, and then plastic box and then foam box. It decreases with the time. But as you can see in our bar graph of our insulation method box, you can see that there is no decrease, not much decrease in the bar graph of ours. So this shows that our bar graph can last longer than the other types of boxes. This cooler will be made by combining different materials that are good insulators. The materials that are needed to construct these coolers are 1. A box, 2. Styrofoam, 3. Spray foam, 4. Aerogels, and 5. Wool. So these are the steps of making the cooler. First, we must line the inside of the box with spray foam. Next, insert the aerogel onto the spray foam. Then, line the aerogel with more spray foam. After this, insert the styrofoam onto the spray foam. Then finally, let the spray foam dry and bond the materials together. Once the main compartment has finished bonding and is assembled, we wrap the container with wool. The special insulated box will be capable of keeping the baked Alaska cool for 8 to 10 hours.
Thank you, Shinari. Now let's talk behind the science. Let's look at how these materials work, shall we? The first materials that we are going to look at is the box. This box is not special, but it is the framework for the container. Every insulator that is used will be either lined or combined with the box. Now, onto the insulators. These insulators work on the same principle, which is the presence of air pockets. The styrofoam contains many air pockets. Even though air has low specific heat, when paired with wool, the styrofoam is capable of carrying out all 3 methods of heat transfer. The wool is an opaque shield that slows heat transfer by radiation, but most of all, it slows heat transfer by convection. It prevents unrestricted airflow. The next is aerogel. Aerogel is the lightest solid on Earth. This is because the aerogel is mostly composed of air. Because of this, aerogel is the best insulator, and when paired with wool, and as mentioned above, is capable of insulating every type of heat transfer. So in order to bond all of these materials together, we need an adhesive substance. Glue can be used, but in order to maximize the insulation capacity, we have chosen to use the spray foam. This spray foam can be used to bond materials together and is also capable of insulating heat. We combine these materials together to achieve maximum insulation capacity. Next, vocab review. I will review the vocabulary mentioned above. Radiation is the transfer of heat through the use of waves. Conduction is transfer of heat through the collisions and vibration of particles. Convection, transfer of heat used in fluids. Cooler, insulated container for keeping food and drink cool. Insulation, creation of a barrier that to reduce heat transfer. And finally, styrofoam, brand of expanded plastic made from polystyrene. Next, spray foam, chemical product created to be used to insulate heat. Aerogel, a synthetic porous ultralight material that is derived from a gel, but the liquid gel has been replaced by gas. Wool, natural fiber produced by sheep. sorry Peter, specific heat, an amount of energy that must be added in the form of heat to 1 unit of mass or the substance in order to cause an increase of 1 unit in its temperature. So, thank you for watching our presentation. See you next time. Peace out.